Let's start with the third example, analysis of truss. Truss is shown in figure by energy method and find all the bar forces. Assume the top chord members to have twice area of cross section of the other bars which have the same section. Okay, so this is a given figure. Okay, this is a given truss. So again it is a energy method. So for energy method, first thing we want to determine the degree of indeterminacy of the truss. Okay, so degree of indeterminacy of the truss is equal to external indeterminacy plus internal indeterminacy. So external indeterminacy is equal to number of unknown reactions minus number of available equilibrium equations. So number of unknown reactions. So from the truss, so at the joint A it is a pinned end and joint D also pinned end. So joint A have two reactions, joint A also two reactions, VA, HA, VD, HT. Okay, there are four reactions. So number of unknown reactions is equal to 4. Number of available equilibrium equations is equal to 3. Okay, so it is a coplanar system, two-dimensional system. So therefore 3 equilibrium equations are available. So therefore external indeterminacy is equal to 4 minus 3 is equal to 1. Okay, the structure externally indeterminate with 1 degree. Then internal indeterminacy, it is determined from the configuration of the structure. Okay, so internal indeterminacy is equal to m minus 2j minus 3 for 2D pin jointed frame. In case of rigid jointed frame like portal frames or beams means we have to use 3c, 3 times number of closed cuts. So it is a truss. For the truss element, internal indeterminacy m minus 2j minus 3. So number of members, there are 10 members. Okay, so there are 10 members. Number of joints, 6 joints. So finally internal indeterminacy is equal to 1. So total indeterminacy, so 1 plus 1, 2. The truss is statically indeterminate both externally and internally with the total degree of indeterminacy 2. Okay, so after determining degree of indeterminacy, we have to select the redundant force. Okay, so the given truss is externally 1 degree indeterminate, internally also 1 degree indeterminate. Okay, so therefore we have to select one redundant from external, from the support reaction, so another one from the internal members. So for this, okay, so from the external I taken HD as a redundant, one redundant from external. Then from the internal members, have to choose member 10 as a redundant. Okay, then this HD is direction I assumed towards left, then redundant in member 10, so it is taken as, its value is taken as F, it is a tensile in nature. Okay, then so we have to apply some compatibility equations. Okay, so by the principle of energy theorem or theorem of least works, so we have to use two conditions: dou U by dou F is equal to 0, dou U by dou HD is equal to 0. With the help of these two equations, we may find out the values of this redundant HD and F. Okay, so since it is a truss, so truss means the axial loaded members. Okay, so external force is always acts at the nodal joints, so therefore the system subjected to only axial forces. Okay, so therefore strain energy stored in the axial loaded member. For the truss member, so strain energy is equal to integration of pi square dx divided by 2a to ae. For the total truss, so in summation of I is equal to, there are 10 members, therefore I is equal to 1 to 10 pi square li divided by 2i ai. Okay, so I varies from 1 to 10. I then differentiate the strain energy with respect to the force. So after differentiating this equation, so finally dou U by dou F is equal to summation of I is equal to 1 to 10 pi dou pi by dou F Li divided by Ai Ei equal to 0. So this term L by AE. It is called as flexibility. Flexibility. So like this. Similarly, dou U by dou HD is equal to summation I is equal to 1 to 10 Pi. So Pi dou Pi by dou HD Li divided by Ai Ei. So first thing, so now the bar force in the truss can be analyzed, and it is expressed in terms of both the external loads and the redundant. Okay, so before going to find out analyze first thing, so in the analysis, first thing we want to determine the support reactions. So support reaction also in terms of external force and the redundance. Okay, so apply 3 equilibrium equations. So with the help of 3 equilibrium equation, we may find out the values of HA, VA and BD. So first equilibrium equation, summation of moment about A equal to 0. Okay, so in this figure, so from this figure, summation of moment about A is equal to 0. So first external load is 40. It acts at the distance of 3 meter from point A. So 40 into 3. It is a vertical force. Horizontal distance is the perpendicular distance. Then again 40 kN. It acts at a distance of 6 meter from the point A. 40 into 6. So both are creates clockwise movement. Then, so we remove the redundant. So we taken a redundant as F10 force. Okay, force in the member 10 is taken as redundant. So we remove that element with the force F. So it is considered tensile in nature. Okay, so remove that member, consider a force along that member. Okay, along that member, that is F. Okay, so it is an inclined force. First resolve this inclined force. So it has 2 components. So at the joint E has 2 components, F cos theta, F sin theta. At joint C also F cos theta, F sin theta. Okay, so first thing we would like to determine the angle of inclination of this inclined members. Okay, so tan theta is equal to theta. So theta all are same. Okay, tan theta is equal to 4 by 3. From theta is equal to 53.13. Sin 53.13 means 0.8. Cos 53.13 means 0.6. Okay, so in the moment equilibrium equation, so 40 kilonewton force at joint E creates clockwise moment, and 40 kilonewton at joint F creates clockwise moment. Then F cos theta, F sin theta at joint F sin theta at joint E creates anti-clockwise moment, minus F sin 53.13 into 3. Then F sin theta at point C creates clockwise moment, therefore that is plus. Then F cos theta at point E creates 0 moment because there is no perpendicular distance. Then so another one force is F cos theta at joint C, it creates an anti-clockwise moment. So therefore minus F cos 53.13 into perpendicular distance. It is horizontal force, perpendicular distance will be 4 meter. Then VD reaction, it is create anti-clockwise moment, VD into 9 equal to 0. From that, VD is equal to 40 kN. Then apply a second equilibrium equation, summation of V equal to 0. So VA and VD is in upward direction, so therefore it is positive. Then 40 is in downward direction, totally 80, minus 80. Then F sin theta is in upward direction. At point C, point E, F sin theta is in upward. Point C, F sin theta is in downward direction. So one is plus, another one is minus. So finally V is equal to 40 kN. Then summation of H equals 0. Apply horizontal equilibrium equation. HA in positive direction, HD in negative direction. Then at point E, F cos theta is in positive x direction. At point C, F cos theta is towards negative x direction, therefore minus. So finally HA is equal to HD. So now analyze the structure. Okay, now analyze the structure and find out the member force. So for this, so first take joint A. Okay, at the joint A we know the value of HA and VA. So remaining are only two unknowns. One is F1 force, another one is F4 force. Okay. So now apply joint equilibrium equation. So our first joint will be first point have only maximum of only two unknowns. Okay, because we have only two equilibrium equations. Okay, so it is a coplanar concurrent system of forces. All the forces are meeting at a single point, so therefore it is a concurrent system. So for the concurrent system we can't use a moment equilibrium equation. Okay, so therefore we have to use only two equations. One is horizontal equilibrium equation and vertical equilibrium equation at the each and every joint. So therefore we have only two equilibrium equation. So our selection point should be less than or equal to two unknowns. Okay, so at the joint A, so we already determined the support reaction VA and HA already known. So other two members are connected at joint A will be member 1 and member 4. Okay, so this can be solved easily with the equilibrium equation. So initially both the forces consider as a tensile force, F1 also tensile, F4 also tensile. The angle between, so the F1 force make an angle 53.13 with respect to the horizontal. So apply vertical equilibrium equation. So 40 is in upward direction, then F plus F1 sine 53.13 in upward direction. So finally F1 is equal to minus 50. So minus represents our assumed direction is wrong. Okay, so initially I assumed it is a tensile in nature, but actually it is compressive force. Then apply horizontal equilibrium equation. So HD towards positive x direction, then F4, then plus F1 cos 53.13. Then finally F4 is equal to 30 minus HD. Then take second joint. Okay, if you are taking joint B means, so we know only the value of F1. So remaining F7, F9 and F2 are unknowns. So there are three unknowns. We can't take the joint because we have only two equilibrium equations. So therefore we have to select the joint that have maximum of two unknowns. Then next select the joint E. At the joint E, so there are four members are connected and one external force is there. So already we know the member force of F4 already determined. Then F10 also known, it is F. Okay, only two unknowns, F7 and F5 are the two unknowns. Okay, so take this joint. So F4. So initial first trial, first we have to assume the unknown force as a tensile in nature. Okay, so F4, F5, F7 and 40. Then apply vertical equilibrium equation. From that vertical equilibrium equation, so we know F7 is equal to 40 minus 0.8 F. Then summation of H equals 0. So from this equation we know the value of this. Then next select, if you are taking F7 means, so there are four members are connected, out of which only one so value of member F5 only known, so remaining three are unknown. So therefore we have to select joint D. At the joint D, so there are two members are connected and two reactions are there. Okay, at the joint D, so VD, HD, then F6 and F3. So apply vertical and horizontal equilibrium equation. So with this F3 is equal to 50 kilonewton. Summation of H is equal to, so F6 is equal to 30 minus HD. So apply equilibrium equations. So at the joint D, summation of V equals 0 means, so 40 is in upward direction plus F3 sine 53.13 equal to 0. So finally F3 is equal to minus 50. Then apply second equilibrium equation, summation of H equals 0. So that means minus F6. F6 is in towards left direction. Minus F6 minus HD. This is also my left side. Then F3 cos 53.13. This is also left side. So finally F6 is equal to 30 minus HD. Then take joint F. So now joint F, only two unknowns. One is F9, another one is F8. First apply horizontal equilibrium equation. So Fi is in left side direction minus F5, then plus F6 minus F9 cos 53.13 is equal to 0. Substitute the noun values. Fi we already known, then F6 also already known. From that F9 is equal to F. Finally F9 is equal to F. Then apply vertical equilibrium equation. F8 positive y direction, then minus 40 is in negative y direction, minus 40, then F9 sin 53.13 in positive x direction, sorry, positive y direction is equal to 0. Then substitute F9 value. Finally F8 is equal to 40 minus 0.8 F. Then take joint C. At the joint C, so there are 4 members are connected, so out of which we already know the value of 3 members. Okay, F3, F8 and F10 are known, so only unknown is F2. So in this joint you may use either horizontal equilibrium equation or vertical equilibrium equation, so whatever it may be. So now apply horizontal equilibrium equation. Okay, summation of h equals 0, so minus F2 is in minus x direction, minus F2 minus F cos 53.13, then plus F cos 53.13 is equal to 0. Finally F2 is equal to minus 30 minus 0.6 F. And after that